Good morning, boys. Welcome back again. We'll continue with our chapter, the periodic table, and we were doing study of some specific groups. They were group number 1, alkali metals, group number 2, alkaline earth metals, group number 17, halogens, and group number 18, inert gases or noble gases. In our previous class, we have already learned about three groups. They are group number 1, alkali metals, group number 2, alkaline earth metals, and group number 17, halogens. We also came to know from our previous lesson that group number 1 and group number 2 are metals, and they are reactive metals, whereas group number 17, they are non-metals and they are also reactive elements. Now group number 1, the reactivity of group number 1 is very high. They are highly reactive. The reactivity of group 2 elements, they are also very reactive, but their reactivity is slightly less than that of the elements of group number 1. Group number 17 elements, that is halogens, they also have very high reactivity. Therefore, whenever group 1 elements, they are metals, alkali metals, and group 17 elements, halogens, which are non-metals, when they come in contact with each other, they react very rapidly to produce metal salt, or we also call metal halides. For example, sodium is alkali metal, group number 1 metal, and chlorine, group number 17, non-metal, halogens. When they come close to each other, they react to form metal halide, that is sodium chloride, which is a salt. We also learned that the valency of group 1 element is 1, whereas the valency of group 2 elements are 2, whereas the valency of group 17 is 1. Now I came to know through some of your assignments that you are still writing valence electron as valency. Do not get confused. Valence electron is not valency for all the elements. Up to group number 14, valency is equal to valence electron, but from 14 onwards, like 15 onwards, 15, 16, 17, the valency will be determined by subtracting the number of valence electron from the stable configuration 8. So group 17 has 7 valence electron, therefore the valency will be 8 minus 7 equals to 1. Okay, boys. So now in our today's class, we are going to learn some important characteristics of group 18 elements or noble gases. Now most of the noble gases, that is, the noble gases are helium, neon, argon, krypton, xenon, and radon. So we have 1, 2, 3, 4, 5, 6 noble gases or inert gases, and most of them are the contribution of William Ramsay. And William Ramsay he was also awarded Nobel Prize for his contribution on noble gases. Now these noble gases or these elements of group 18 are called noble or inert gases because these elements, they do not react at all. They are very, very inert. Inert means they don't have the tendency to react. Why? What is the reason behind that? The reason behind that is, if you see their electronic configuration over here, helium has only one cell, first cell, and it has 2 electrons. So this will be the valence electron, and we know the law of stability duplet. According to duplet law, if any element has 2 electrons in its innermost or the K cell, the first cell. If any element has 2 electrons in its K cell, which is also the valence cell, then that particular element is very stable. So in case of helium, there is only one cell, so this will be valence cell, K cell, and in that K cell it has 2 completely filled cell. So this completely filled duplet cell makes helium very, very stable. If you see other noble gases, they all have 8 valence electron. Valence electron means outermost electron. So they all also fulfill another stability law, and that is octet law. According to octet law, elements having 8 electron in its outermost cell are stable. So if you see over here, they all are stable, and atoms, all the atom wants to be stable. If they are not stable, if they don't have stable electronic configuration, all the atoms tends to gain stability. Therefore, to gain stability, they react with one another. But in case of these noble gases, they already have stable electronic configuration. Therefore, they do not need to react with other elements to attain stability. Hence, they are called inert. Why? Because they do not react at all. Now let us see some other important characteristics of noble gases. So we have already discussed about electronic configuration. Okay, so neon has 2 atomic number, helium has 2 atomic number, neon has 10, argon has 18, krypton has 36, xenon has 54, and radon has 86. So you can distribute or write the electronic configuration with the help of their atomic numbers. Now all these noble gases or inert gases, they are colorless, they are tasteless, and they are odorless gases. They all exist in gaseous form. They neither have color, they nor have taste, and they do not even have any odor. They, unlike oxygen, they are not non-inflammable, and they do not support combustion. They don't burn also. Inflammable means they do not burn, they do not catch fire, and they do not support combustion. That means they don't help others to burn also. Let's move to another characteristics. All these noble gases, they are monoatomic. Monoatomic means their molecule is made up of one atom only. Why their molecules are made up of one atom? Because they do not need to combine with another molecule of same atom also, because their electronic configuration is already stable. So since they have very stable electronic configuration, their molecule exists in monoatomic form. Let's see another important characteristic of these noble gases. These noble gases, when they are subjected to electricity in a discharge tube, electrical discharge tube, then they emit color. Remember, these gases are colorless, but when they are subjected to electricity inside a electrical discharge tube, then at that time these gases emit colored light. Okay, when electrical discharge, electricity is passed through them in a electrical discharge tube, then they emit colored lights. And this property of this halogens are used in our street lights, glow signs. Okay, because different gases, when subjected to electricity in an electrical discharge tube, like tube lights are like discharge tube. Okay, they emit different colored lights. The color of light that we see in a street board signboards like yellow, blue, red, all these colors are produced due to noble gases. Let's see another property, melting point and boiling point. All these noble gases, they have extremely low melting and boiling points, and they cannot be solidified. They are all gases. So even helium has the lowest melting point among all these noble gases, and it is very, very difficult. In fact, we cannot convert helium into solid helium. Why? Because these gases are very, very stable gases. They like to be in their own state, and therefore they do not change even their physical form also. It is very, very difficult to change their physical appearance. Like they cannot be brought to solid state. Is that clear, boys? Now let's see some important uses of these noble gases. The uses of noble gases depends on their unreactive nature. We all know all the noble gases are inert. That means they are unreactive in nature. They do not react with others. So this inert nature of noble gas in some places becomes very, very useful. For example, helium is used in airships and balloons because these heliums are light as well as unreactive. Now if we use, instead of helium, if we use other gases such as hydrogen, oxygen. Hydrogen and oxygen, they are reactive. Although hydrogen is light, but it is reactive. Therefore, what can happen? It can react with oxygen to form water, and hence the purpose of lifting balloons, the purpose used in airships might not be fulfilled properly because of their reactive nature. But helium is light as well as unreactive, and that is why compared to hydrogen, helium is more preferred in airships and balloons. Now I already told you that these noble gases are also used in signboards made of lights. Okay, and the most commonly used noble gas are argon and neon. Now argon gas, noble gas, does not react even with the filament which is there inside the bulbs. Now whenever we switch on the light, we get light, the bulb emits light due to the heating of the filament present inside the bulb. Now that filament reaches very, very high temperature inside the bulb, but this argon gas does not react with this even very high, the filament having very high temperature. Therefore, due to its very, very unreactive nature, this argon gas is used in light bulbs. In colorful light boards, we use neons, like I have already told you about this, because these gases, when electrical discharges pass through them in a discharge tube, they emit different colors. So this is all about some of the important characteristics of group 18 elements. They are noble gases. I suggest you to go through your textbook in detail to see some other characteristic properties of group 18 elements. I want you to learn their electronic configurations, their basic characteristics such as their character of molecule, monoatomic molecule, their unreactivity nature, inert nature. Remember, noble gases, the valency of noble gases is 0. Why? Because they have 8 electrons, which is the stable configuration. Therefore, they do not need to react with any other elements, and they are used in electrical bulbs as well as glow signs. This much for today, boys. I have also attached another video which contains explanation of answers given in previous assignment. I have made this video because many of you were not able to answer those 3 questions properly. So I suggest you to go through that video also. Check the answers, understand them, and do your correction. Until then, stay safe and do all things well.